Hi students. So in this video we are going to discuss about properties of sets. Properties of sets. So let me consider properties of sets. Properties of sets. So how many properties are there? We have four types of properties are there here. So first one is commutative property. Commutative property. So next one is associative property. Associative property. Next one is distributive property and demorgans laws. We have to discuss these four types of properties now. So first we are going to discuss commutative property. Commutative property. Commutative property. Commutative property over union first. Commutative property over union. So what is commutative property over union? So we know A comma B are any two sets. Let A comma B are any two sets. A union B is equals to B union A. A union B is equals to B union A is known as commutative property. A union B, how to fill this is in. So A union B and B union A we have to consider by using Venn diagrammatic format. Venn diagrammatic format. So you can see Venn diagrammatic format. This can be written as, so A, this is mu, this is A and this is B. So this is A and this is B. This is called A union B. A union B means what? All the A elements and all the B elements and the A union B, A intersection B elements also one time we have to consider. Next coming to B union A. So this is B and this is A. So here also B elements and A elements and the intersection part element. That means both are same regions. Same regions. So let me consider A is equals to 1, 2, 3, 4 and B is equals to 3, 4, 5, 6. Then A union B is equals to set of 1, 2, 3, 4, 5, 6 elements. 5, 6 elements. Why? Because all the A elements we should consider once. Then B elements. So here common elements will be taken already. That's why we should not consider the common element once again. Then 5, 6 were taken additionally. Then B union A. What is B union A? So B is 3, 4, 5, 6. What is A? A can be 1, 2. Already 3, 4 is there. 3, 4 is there again. So that means even though the order will be changed according to immaterial of two sets, immaterial of sets, immaterial roster form will be immaterial. That can be, so if order will be changed, the elements should be same. Here 1 is there, 2 is there, 3, 3, 4, 4, 5, 5, 5, 6, 6. That means each and every element of this set belongs to each and every element of this set. So that's the reason why both sets are equal. Both sets are equal. We can verify it by commutative property by using original method or Venn diagrammatic method. Then coming to intersection over intersection. So it will be taken as over intersection. Intersection. Commutative property over intersection. Here also same commutative property. A intersection B is equals to B intersection A. Then what about intersection values? So intersection values we can consider A intersection B is nothing but both common elements we have to keep. This is 3, 4. And B intersection A, B elements 3, 4, 5, 6 and A elements 1, 2, 3, 4. The common elements will be 3, 4. That means A intersection B is equals to B intersection A. Then here, so what is the Venn diagrammatic form? Venn diagrammatic form is also, so this is A and this is B. So this is A and B, common elements will be here. So here also this is B and this is A. So common elements will be here. So that means in both the cases we are getting common elements. Then that also both are same. That's the reason why. So commutative property over intersection also verified. Commutative property over intersection also verified. Then we are going to consider associative property. Associative property. So in this case, associative property, we should consider 3 sets. We should consider 3 sets. Associative property. associative property. Let A, B, C or any three sets A, B, C or any three sets, then A union B union C is equals to A union B union C. So first we should consider A union B elements. After that we are going to make union with A. So here we are going to consider A union B first. After that we are going to union with C. So this is about associative property. Associative property over union, and same as associative property over intersection we are going to consider. Let A is equals to 1, 2, 3, 4. B is equals to 3, 4, 5, 6. Next C is equals to 5, 6, 7, 8. So this is three sets we should consider now. First we have to verify A union B union C. First A. A means what? A means 1, 2, 3, 4. Bracket. So union. So first you have to consider. So 3, 4, 5, 6. Union 5, 6, 7, 8. So now this is 1, 2, 3, 4 union. So what is about union? This is 3, 4, 5, 6 and 5, 6, 7, 8. That is 3, 4, 5, 6. You have to write first elements all. Then what are the common elements we should consider? 5 and 6, 5 and 6. That common elements we are taken remove, and so common elements were only consider only once. Then remaining 7 and 8 we have to consider like this. So this is called A union B. So now union you have to consider 1, 2, 3, 4. First all the elements of first set we are going to consider. Now if common elements is there, yes, it is common elements 3 and 4. That means already we taken 3 and 4. That's why we should not consider again 3 and 4. So because of set does not allows the repeated elements inside of roster form. That is 5, 6, 7, 8. So this is about A union B union C. Now coming to A union B union C. Let me consider A union B union C. First A union B we have to consider A 1, 2, 3, 4. Union B is 3, 4, 5, 6. So first we have to consider these two. Then union of 5, 6, 7, 8. So you have to consider both this union first. 1, 2, 3, 4. Already 3, 4 is there. That's why 5, 6. Union. This is 5, 6, 7, 8. So again we have to consider 1, 2, 3, 4, 5, 6. Already we should consider first elements. Next second elements is, so 5, 6, 7. Already 5, 6 is there. That's why 7, 8. So if you consider 1, 2, 3, 4, 5, 6, 7, 8. Here also 1, 2, 3, 4, 5, 6, 7, 8. Then so both are satisfied or verified. That means the associative property over union is verified. In the same way you have to try intersection. Then how to find that? So how to draw A union B union C. That is A, B, this is C. So three sets we have to consider. A, B, C. This is new. A union B. A union B means what? All the A union B elements you have to consider once. Union C also we have to consider all the things. All the elements we should consider like this. So here also A union B first. So later, so A union B and B union C. Now A union B union C. How will we consider? A union B union C. This is A and this is B and this is A, B, C. First we have to consider A union B part. B union C part. B union C. First B union C we have to write. So later A union. We also have same. Both will be the same. So that's the reason why. So associative property is verified for union. Now coming to intersection. So intersection means same. So we have to convert this as a simple cap. So cap by using cap. So you have to write like this. So intersection parts. So how to verify the intersection by using Venn diagram? We have to check once. Venn diagram. This is A and this is B and this is C. A, B, C. So you have to consider like this. This is mu. First A intersection B we have to consider. B intersection C we have to consider. B intersection C. This is only B intersection C part. Intersection C, intersection A should be intersection. This is intersection. A intersection. This is. So this is called A intersection B intersection C. A intersection B intersection C. So only this intersection part we have to consider. Now, so A intersection B intersection. First B intersection C we have to consider. B intersection C intersection A. So that is also only intersection A considered we have to take. Okay, next, like that we have to verify. So all the intersectioning and union of associative properties. Next we go for with the distributive property. What is distributive property? How to verify the distributive property? First, distributive property. What is distributive property? Distributive property, first we are going to union over intersection. Distributive property is union over intersection. First, union over intersection. Union over intersection. This is distributive. So as the name itself it is told that first union, after that intersection we have to consider. So like A, B, C are any three sets. A union B intersection C, or A union B intersection C we have to consider. A union B intersection C. So A union B intersection C we have to consider. Okay, so now A union B intersection C. So A union B intersection C. So A union B intersection C we have to consider. First union, after that intersection. So how to distribute this one? By using distributive property. First A union is distributed to B, that is A union B intersection. So A union is distributed to C, that is A union C. So this is a formula. So we have to verify this formula by using examples. So let me consider A. A is equals to 1, 2, 3, 4. B is equals to 3, 4, 5, 6. C is equals to 5, 6, 7, 8. So we have to consider like this. For example, better example I am taking like this. So first, so we have to verify A union B intersection C part. First, so to verify this one, so we need to consider only first B intersection C part. So B intersection C. What is B intersection C? B intersection C is equals to B is 3, 4, 5, 6. Intersection C is 5, 6, 7, 8. So we have to consider only intersection part, that is 5, 6. So now A union B intersection C. A is 1, 2, 3, 4. Union intersection is 5, 6. So these two union 1, 2, 3, 4, 5, 6. So this is about LHS part. Coming to RHS part. So to find RHS part, we need to consider union B first. A 1, 2, 3, 4. Union B is 3, 4, 5, 6. So you have to consider union 1, 2, 3, 4, 5, 6. This is called A union B. Then coming to A union C, we have to consider A 1, 2, 3, 4. C can be written as C is what? So this is 5, 6, 7, 8. So union is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So this is called A union C. Then whereas coming to A union B intersection A union C, this can be written as A union B is 1, 2, 3, 4, 5, 6. Intersection. This is 1, 2, 3, 4, 5, 6, 7, 8. So what is intersection part? Intersection part 1, 2, 3, 4, 5, 6. Yes, here also 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now both are same. So that's the reason why. So this distributive property is verified over first union after intersection. Union over intersection. Later we have to discuss about so intersection over union. Intersection over union. Intersection over union. Intersection over union. So both you have to change in the place of union and in the place of intersection. So if you change union plus intersection and intersection plus union, so this formula is verified. So sets, it is a very important nature is there, that is called duality of sets. Duality of sets. Duality of sets. Duality of sets or duality nature, dual nature. If any problem, any formula you have to consider in the distributive property or whatever the property we are going to consider. So if you change union as intersection and intersection as union, then we get same results. So this is called duality of sets. It is also very important point, duality of sets. So next, so we are going to discuss about De Morgan's law. So De Morgan's law. So what is De Morgan's law? So we have to verify De Morgan's law. So De Morgan's law is nothing but complement nature. De Morgan's law. De Morgan's law of sets. So you have to consider De Morgan's law. A union B whole dash can be written as A dash intersection B dash. A dash intersection B dash. Okay, so we know how to find A union B. First, A union B can be represented. A union B whole dash is nothing but mu minus A union B. Mu minus A union B. So if you consider x belongs to A union B whole dash, that is equals to x belongs to mu minus, so x belongs to A union B. So like this we have to consider. So later we have to discuss like this. So let me consider Venn diagrammatic format. This is Venn diagrammatic. How to find Venn diagrammatic format? This is A union B whole dash. So A union B. So this is A, this is B. This is A and this is B. So A union B whole dash is nothing but you have to shade. So without A union B region. We have to shade. So this is find A union B. Without A union B, you have to region. Now, so how to find A dash intersection B dash, we can see now. So A dash. So what is A dash? So A dash can be represented. This is A and this is B. So this is U. This is A and this is B. How to find A dash? A dash is nothing but except A. Remaining you have to consider. Except A, you have to consider remaining portion. So remaining portion. This is called A dash from this. So now what is B dash? So B dash is nothing but you have to consider except B. This is A, this is B. Except B we have to consider. Except B. So this is called B dash. So now A dash intersection B dash. That means both common elements we have to consider once. So both the common elements we have to consider. So that's the reason why we should consider both the common elements first. So both the common elements is nothing but, so both the common elements we have to consider. So here both common elements not there. So common elements is there. Here only A is there and only B is there. That's the reason why. So we should consider this is both the common elements is like this. This is mu, this is A and this is B. So both the common elements we have to consider like this. Okay. So now understood what is the De Morgan's law. So coming to De Morgan's law, already we know dual nature of sets. So if you take here intersection, it will become union. By changing intersection and union will be difference. Any formula we have to prove like this. So this is called dual nature of sets on De Morgan's law. So next we have some important results. Now these are the important results regarding De Morgan's law and base formulas regarding sets. So A dash whole dash. A dash means not A. A dash means not A. That is except A. So that is also dash. Whole dash means again A. So A dash whole dash. Two times we are giving complement to any set. It becomes same set. Original set will come. That is A union A dash. A union A dash. A union A dash is equals to mu. So A union, that is A is joined to A dash. That means A not there. So here A not there set. So except A and A union. That means we are combining except A. So without A, remaining all portions we are considering here. That A portion also including means again we are getting universal set, that is U. So A intersection A dash. A intersection means common region. Intersection means common region. Here A will be, A dash means not there. So if A not there and A is going, that means that is called both are disjoint sets. That's the reason why it gets 5. 5 is called null set. 5 is called null set. A minus B. What is A minus B? A minus B means what we know that what is the difference. So we are consider only A elements, not consider B elements. That's the reason why A and not B, that is B not. Okay, if we are not considering B, so A and B dash, that is called A minus B. Like that B minus A, B and A dash, that is except A not there. Okay, so now consider A minus B union C. A minus B union C, that is also very important. A minus B union C can be written as A minus B intersection A minus C. If minus is going to inside the bracket, the union becomes intersection. In the same way, dual nature. In the place of union, we can say intersection. That means in the place of intersection, we can say union. That is called dual nature of sets. Like that, we have verified some important results. Now some results based on cardinal number. Cardinal number also we have to consider some type of results. Let me consider. This is cardinal number results. Some n of A union B is equals to n of A plus n of B minus n of A intersection B. So this is a formula very important. Like that we can consider. So n of A intersection B is equals to n of A plus n of B minus n of A union B. We already know the dual nature here. In the place of union intersection, in the place of intersection union we can consider. Next, if A comma B are disjoints, A comma B are disjoints, that means A intersection B is equals to null set, then of A intersection B is equals to 0. N of A intersection B equals to 0. In this case, N of A union B can be written as N of A plus N of B. N of A plus N of B. Like that we can consider N of A plus N of B. Then, so what about so N of A minus B. So what about N of A minus B? N of A minus B is equals to N of A minus B is equals to N of A minus N of A intersection B. N of A minus N of A intersection B. Like that N of B minus A also. So N of B minus N of A intersection B. So like that we can consider. So all the examples. Okay. So okay students, now we are going to finalize the sets introduction parts. So if you have any doubts regarding sets, you can please message me. Okay, I will try to rectify all your doubts. Thank you.